Hey guys, here is the lab report part of the videos. So I'm just kind of going to go over what some of this data means. I know it's just a bunch of graphs. But so basically what this is showing is what they did is they collected all the data and they read the absorbance from the spectrophotometer over time. And on this first graph, they did it just concentration on the y-axis and time on the x-axis. And then they took the concentration and they took the natural log of concentration and they graphed the natural log of concentration on the y-axis and time again on the x-axis. And of course, remember, we want these to be a straight line. The different orders of the reaction correspond. They'll be straight depending on whether it's a straight line or a curve. So basically, we're able to find the concentration over time of specifically the CV plus from these graphs. So what we're finding is, so rate is equal to K observed times the concentration of CV plus raised to whatever order it is. And you can determine the order from which graph is straight. We see this graph 2 as a straight line, so we'll want to figure out which order that natural log of the concentration corresponds to. So now that we have this rate, so now that we find the order in terms of CV, we've also done different concentrations of NaOH. You see we have, let's see, these correspond, these are the same concentration, these two are the same concentration, 0.05, and this one is the same concentration. So basically what's happening is, remember, we know the order of the CV plus, and if you look in your lab manual, you can see, or even in your lab report, it asks you for a whole bunch of ratios. It asks you for like the ratio of K observed 1 over K observed 2 is equal to, so for like 1, if it's 0.05 molar, it's going to be 0.021. Remember, this is a negative K is the slope. So 0.021 divided by 0.05, I suspect that these are, this is 1 over CV. So these are all three. So basically they gave you the one with the straight line for all of these. So these are all the same. This is 1 over the concentration. And again, that's not a straight line either. So it's this one that corresponds to the straight line is the order. But anyway, so K observed is 0.021. This K observed is 0.0375. And it's raised to some power x. And you can compare is equal to the ratio of the rate, so 0.050 divided by 0.10. And you can figure out what this order x is based on that. And so that's how you figure out that's how you can find both the concentration, both the rates, the orders of the reaction with respect to both the CV plus, since basically we're grouping this K observed as being the concentration of OH minus times K. We're just grouping that as one. We're calling that the same thing because like in this reaction, the concentration of, so basically we're just grouping that as one thing, and we're assuming that we can just kind of keep that constant as K observed. Hope this helps. Thanks for watching.